We're going to take a look here at the pirate treasure problem, which I always enjoy doing. So you can see here we have this information about these pirates. We've got this nice drawing here. 200 feet out, this graph would be 50 feet below sea level, basically. Looks like it's crossing through the origin, although actually that could be open to question. And then 400 meters the other direction, this thing hits a maximum height, and the maximum height is at 150 feet. So we need to put this together and come up with an equation for this thing, and let's see what we can do here. All right, so first of all, the amplitude. Notice this goes as low as -50, and it goes as high as 150. So that is a total distance of 200 meters. The amplitude, of course, will be half of that. So the amplitude is going to be 100 meters. The midline is going to be halfway between the 150 and the -50. So I usually just average the two. Just add 150 and -50 and divide by 2. And if you do that, you end up finding out that the midline is going to pass through 50 when you work that out. And again, there are different ways to approach that, but that's how I would do it. Some people would just count down from the maximum value. They would say, if you're 150 feet up, go down 100 and you end up at 50. But technically y equals 50 there, but shifted 50 units up. All right, the phase shift here. This looks like a sine function, okay? It looks like it passes through the origin here. It doesn't actually give us that point, okay? I don't think we want to make that assumption. And as a result, the point that we know for sure is that the maximum value here is at the point 400, 150. So I think that's a little safer point for us to use. If that's the case, we need to use a cosine function here, shifted 400 units to the right. And then finally, the period here. And you do need to be careful with the period. Notice that the function here is going to continue. Whoops, sorry. Function's going to continue here, and it doesn't finish a full cycle from minimum to maximum. That's a length of 600. That's only half of a full cycle. It's going to go another 600 over here till it gets back to the same place that it hit that minimum value over there. So as a result, the period is 1200. Okay. And if the period is 1200, then what I really want to do here is set the period of 1200 equal to 2 pi over b. And if you cross multiply and you solve, b is actually going to be pi over 600 is the final value there. That doesn't look like 600, but take my word for it. B is pi over 600. So if we put all this together, what do we have? Well, we have y equals amplitude of 100. We're using a cosine, and we're going to use a pi over 600. We are shifting it 400 units to the right, so that would be an x minus 400, and then we're going to shift it up 50 units, and I'm just about off the screen there. Hopefully you can see that 50. So again, that's 100 cosine of pi over 600 times the quantity x minus 400, and then you're adding 50. I know that's a little bit hard to read there. Anyway, we're going to pick up with other parts of the problem in another video in just a moment.